Click the bell icon to get latest videos from Ekeeda.
Hello students, so after the third problem, let's move to the next problem, that is problem number 4, which is on separating the given hyperbolic function into real and imaginary part. So guys, this time here we have the more difficult function, and here I am gonna tell you how we can separate that function into real and imaginary part. So pay attention towards the video and watch this video carefully. So now guys, here x plus iy is given as tan of pi by 6 plus I alpha, and we have to prove that x square plus y square plus 2x upon root 3 is equal to 1. Now guys, the question is, in the question, in the given term, there is a complex number, but in the prove that we want square of each term. So we want x square, we want y square. Now the question is how to achieve it. So let me tell you that whenever you have a complex number and you want square of its real and imaginary part, then that time you should take the conjugate of the complex number, because if you take the conjugate, if you multiply it, then you automatically get the square. So what I'll do here is, first of all, whatever is the given term, I'll call it as equation number 1, and we'll find the conjugate of that term. So here, so now guys, I'm finding the conjugate. So x plus iy will be x minus iy, and this will be tan of pi by 6 minus I alpha. That is equation number 2. Now here, as I want this equation, to get that equation, what we'll do is, here we have tan of pi by 6 plus I alpha, here we have tan of pi by 6 minus I alpha. So guys, we will find the value of tan of pi by 3. So if I want to find the value of tan of pi by 3, that is nothing but tan of pi by 6 plus I alpha plus pi by 6 minus I alpha. So it means if I add these two angles, then that will give me pi by 3. Now guys, you must be thinking that why I am finding the value of tan of pi by 3. Well, let me tell you that if you observe this result, then here in the denominator we want root 3. Now guys, you all know that the value of tan of pi by 3 or tan of 60 degree. So in that we get root 3, and we can shift that root 3 to the other side, and that can go in the denominator and we can get the result. Now here we got tan of pi by 3. Now the question is how to solve this term. So we'll consider this first term as A, and let's look at this second term as B. So guys, it means this is a formula of tan of A plus B. So we know that it is tan A plus tan B upon 1 minus tan A into tan B. So yes, we'll write that formula here. So A is pi by 6 plus I alpha, and B is pi by 6 minus I alpha. So now guys, on the left hand side we have tan of pi by 3, which is root 3, and now we'll put the values of each and every term. So tan of pi by 6 plus I alpha is x plus iy, and this is x minus iy. So we'll put these values. So here we'll get, now guys, here if I add it, so iy cancel, we will get 2x upon 1 minus, if we multiply these two brackets, then we'll get x square and minus I square y square. Now guys, I square is minus 1, so that will become plus y square, and this is root 3. Now guys, here let's see the result. So we have to prove this. So to prove this, what we'll do is, we'll take this term to the left hand side and we'll shift this root 3 to the right hand side. So 1 minus x square minus y square on the left hand side, and here 2x upon root 3. Now we'll take this x square and y square on the other side. So we will get 1 equal to x square plus y square plus 2x upon root 3. And guys, if I rewrite this term, so that is nothing but our required result. So this is what is required in the question. So you can see here that we have proved the required result. So guys, I am sure you understood how I have applied the rule and how I have used the conjugate of a given complex number. So you just have to follow the same process, and with that you also have to do one thing which I am sure you have already done, that is to subscribe to Ekeeda channel. Because guys, if you are watching this video and if you have not subscribed, then let me tell you that you won't be able to get the latest updates or new videos of Ekeeda. So it's your choice. Do subscribe and follow the Ekeeda channel, because in the next video I'm gonna cover more numericals on hyperbolic function. Thank you very much.